All right, we're on the lesson about transformations of center and spread. And so, what we have in your notes is an activity that we were going to go through and put these 40 pieces of data into our calculator and then do all these transformations and see then what are the effects of those. Well, because we're here at the end of the semester, then we've kind of run out of time, and I think that we might get bogged down in all the calculator functions of this and how accurate we get these 40 points in there and so on. So instead, we're going to do a visualization representation of these transformations and how they affect center and spread. And then after we just look at this visualization, we'll summarize it, and then you'll know those rules of those effects. So here we go. So we're going to talk about how do these transformations, and what I'm talking about is adding, subtracting, multiplying, or dividing. How do those affect these measures of center and spread? And so based on the last quiz, it became apparent to me that some people don't even have clarified in their brain what this thing called a measure of center is. Well, that's your general idea of representing the data, the center of the data. So that's either the mean or the median, and we've talked about which one to use when. And the measures of spread, how varied the data is. And that's your standard deviation or IQR. Now, let me just go ahead and show you a context problem of how this might work in real life so you understand where we're headed with this. Okay. So suppose that we want to take the number of college hours that you decide to take. So what you're going to take next semester, or let's say in the fall, whenever you have your first semester at college. And so we want to transform the number of college hours into the cost for that number of college hours. So here's a simplistic equation of what the university charges. They will charge a student supply fee or a student services or a registration fee, okay, and in this case, 150 plus $100 per semester hour. So what we have is our original data, which is the average and the median, the standard deviation and IQR of how many hours a student typically takes in a semester at college. Okay, so the average is 15. The median, the center of all of those options is 12. Standard deviation, how spread out, varied it is 5 with an IQR, that middle 50% of 8. Okay, so let's go ahead then and look at how our transformations will affect our data. So to visually represent this, we're going to use these little spheres. Okay, and so I have this in my classroom. If you can envision, I should have brought it up here, but if you can envision, here is the ball, and you can pull it and stretch it apart, and then it looks like this. Okay, so we're going to use that representation. Now, let's first talk about measures of adding and subtracting. So if this is the collection of all of our data in a graph, okay, so I'm going to center it here at, I guess, 1. Okay, so I'm going to center it there at 1, and then you can kind of see it looks to me like it's about 2 wide. Okay, so that's how the spread is. This case, that's the range because I don't know how many points there are and everything. So let's say the high minus low is 2. Okay, so we got a spread of about 2 in this case. The center is about 1. So that's our mean and our median. So let's talk about a transformation. Like, for example, if I, instead of our real world problem of adding $150 for the services, what if I say added 5 to every piece of data? Let's say I added 5 to each student's service or each piece of data. So I'm going to add 5 to each piece of data. If I do that, then what's that going to do to the location of this on the number line? Well, that's going to shift it So adding 5 will shift it up 5. Of course, if I subtracted, then I would shift it left into the negatives. So you can see that a shift is changing one of these, at least one of these measures of center. What is changing? The mean and the median is no longer centered at 1. The mean and the median is now centered at 5. Now, the spread previously, like the range, because that's a measure of spread also, had previously been 2, going from 0 up to 2. And so, because I don't know exactly what the standard deviation or IQR is, if I move this up, did the spread change? And that answer is no. So what we have, hopefully you can see that. And so this is a key point number 1. Okay, key point number 1, adding and subtracting affects center, but not spread, how spread out the data is. Okay? All right, very good. So that's our first major point. Now, let's go back. Let's go to the next idea. The next idea is this idea of multiplication and division. Well, that's this stretch or a compression. So I want you to visualize that kind of with this. So say let's see, this is going to go about maybe twice as big. So let's say that here I have, a spread of 2. I'm going to multiply by 2. If I multiply by 2, then it's going to go from being 2 wide to 4 wide. So I stretched it out. And so it went from being 2 wide to now being 4 wide. Look at the center. The center also changed. So the center previously was 1. See, previously the center was 1, but now it looks to be centered at 2. Okay, so that is, in this case, I showed multiplication. And so then I could do the opposite. I could take this data set and I could divide it by 2. If I took this data, which is 4 wide and centered at 2, if I divided it by 2, then it would look like this. It would have been compressed, and it would be 2 wide, 2 units wide, and it would be centered at 1. So let's summarize then what we have determined. So big idea number 2 is that multiplication and division affects what? Did multiplication change the center? Yes, it did. It changed it from being centered at 1 to now being centered at 2. Okay? Did multiplication change the spread? It was 2 wide, and now it is 4 wide. So yes, it changed the spread. So in summary, multiplication affects the center and spread. Okay? The center and spread. All right, so that's our second big idea. And so that's it. That's then what we're going to use to then go forth and answer our questions in context. So that's how transformations affect center and spread. In fact, on the next page, or the page that you have, and I think it might be page 29, we could come down here to the bottom and we could summarize that. So let's do that so that you have that written down. So here we go. Summary. So we've got this summary here. We want to add a constant. And what will adding a constant change? Well, I saw that it changed the mean. And I saw that it changed the median. Remember, adding shifted up and down. It changed the mean. It changed the median. It would also, any measure of position. So even like your min and your max can change. So any measure of position changes. Okay. These are all measures of center. Okay, the measures of center. Also, if you had, wanted to make a broader generalization to measures of position. Okay, next, when we multiplied, that's that stretching of the ball. What happened? What changed? Stretching did what? It affected the mean and it affected the median. But it also affected the standard deviation and the IQR. It's affecting everything. It's affecting measures of both center and spread. Okay, so now you've got to remember that. So let's go through our real world example that we were looking at and see how that comes out. Here we go. We talked about this right at the beginning. We want to transform the number of college hours into the cost. So this university fee is $150. So we're going to say our cost equals $150. That's a flat fee plus $100 per semester hour. Okay? Algebra. That's stuff you've been doing mathematically in your classes with functions. Okay. So here we go. So what if we had a mean number of hours? What if the number of hours was 15? So what would that do? How would we change and transform our hours into the cost? Well, hopefully you see that we would just go ahead and plug that in. So here we go. We got our cost. I want that to be a different color. So we've got our cost is, let's see, $150 plus $100 per hour, which 15 hours. Okay, so let me see what that is. I have to do this quick math. So 1,500 plus 150. I hope that that's 1,650. I struggle with adding and subtracting and multiplying. Okay, I struggle with arithmetic, so hopefully that's what we got. So what that's saying is that on average, the students will take 15 hours a semester, and the average cost they will have is $1,650. So that's how we figured out then what the average cost per student, instead of like taking all the student costs and averaging them out. Okay, median. Do the same thing with your median. Cost equals your $150 fee plus your $100 times your 12. So that's going to be 1,200 plus 150. So I think that is 1,350. Okay, so the median cost. Now, big idea number one, do you remember up here? Adding and subtracting affected the center, and so that was why we could do this plus 150 to affect mean and median. Plus 150, yes. And multiplication and division also affects center. So that's why we did the times 100. So addition and the multiplication affected mean and median. Okay, but let's take a look here. How spread out is this data? Okay, we're gonna shift it up $150, and then we're gonna multiply by 100. So we take our 5, take our spread of 5, shift it. Look at what that shifting did. Took our 5, shifted it. It did not change a thing. Shifting $150 had no change on the standard deviation of spread. What does change it? The multiplication. See this here? The multiplication and division affects center and spread. The adding did not affect spread. So that means that when we figure out what the spread of our costs are, then we do not do the plus 150. All that we do is the $100 times the standard deviation. So the standard deviation of cost, variability for costs from student to student is $500. The middle 50% of students spend this much in a semester. Let's see here. No plus 150. So the middle 50 I'm sorry. This is not how much the middle 50% spend. This is how spread out the middle 50% of students are. So that is times 8. So the middle 50% of students spends $800. Okay? So that's how varied the middle 50% of student costs are. So there's how we do that. Now I want you to do the same thing right over here on this page. Come on down here. We just summarized. Now look here. I have a distribution with the following statistics. There's not context here, but we're just going to go through the math. If I take an observation and I multiply it by 4 and add 6. So what is my function if I'm going to multiply it by 4 and add 6? Y equals 4x plus 6. All right, so I want you to take this function. Here is your original data. This is going to be your x. Take your original data through this function and transform it to get your new values. So take a few moments to do that. Do that now. Look here what happened. I don't know what this comes out to be. I think it's like 107 point something. You can math that out. But look here, these spreads, standard deviation, only multiplied by 4, no adding 6. No adding of the 6. Same thing here. The IQR was 8. When I multiply it by 4, it is an IQR of 32 for the new value, and that is because we have no adding of the 6. Okay, because those are measures of spread. All right, so there is your physical look at how transformations change our data. And we wanted to do this with a picture instead of going through and doing that with the calculator functions and kind of getting bogged down in that calculator activity. All right, so hopefully you can take this information and apply it to new and different situations that you would see in our problems and in real life.